Chemical bonding, when two or more than two atoms combine to form a compound, they do so by making chemical bond. Chemical bond, the attractive force which hold together the constituent atom in a molecule is known as chemical bond. Type of bonds. There are three kinds of bonds, namely electrovalent bond or ionic bond. Second, covalent bond and co-coordinate bond. Electrovalent bond. The chemical bond formed by transfer of electron from one atom to another is known as an electrovalent bond or ionic bond. Take the example of sodium chloride, NaCl, where sodium and chlorine atom approach each other. Sodium 281 donates one electron to form Na plus 28, which has an electronic configuration identical with nearest noble gas neon 28. The chlorine atom 287 takes up one electron and becomes chlorine minus 288, which is argon-like. Two oppositely charged ions Na plus and Cl minus are held together by electrostatic force of attraction existing between them as shown below. Na plus Cl by sharing by giving one electron, NaCl compound is formed. When a metal reacts with a non-metal, transfer of electron takes place from metal atom to the non-metal atoms. An electrovalent or ionic bond is formed. Conditions favorable for the formation of ionic bond. Cation formation, lower ionization energy. Greater is the ease with which the cation is formed. Valence electron can be lost easily by large atoms. Third, the ion with lower charge is made easily than the bond with higher charge. Fourth, ions having electron configuration similar to zero groups. Elements are more stable than those which do not have such configurations. Anion formations. Anion formation. Larger the electronegativity of the element, more is the tendency for its atom to gain electron, as the anion is more readily produced. Second, in smaller atoms, lesser is the distance between the nucleus and the valence orbit. The force of attraction of the nucleus over the incoming electron is more. The anion is produced more readily. Third, the ion with lesser charge are more readily produced than those with a higher charge. Crystal lattice in an ionic compound crystal, each ion is surrounded by oppositely charged ions. Ions arrange themselves at optimum distance with a regular periodicity in a well-defined three-dimensional network called crystal lattice. Lattice energy. The energy released when gaseous positive and negative ions are brought together from infinity to form one mole of ionic crystal is called lattice energy. Energy change in the formation of ionic bond. Born-Haber cycle. The energy change in the formation of ionic crystals from the elements can be calculated by using Born-Haber cycle. This is based on the principle that energy change in an electronic is same whether it is brought about in a single stage or in a multiple stage. By Born-Haber cycle, calculating the electron affinity values of some element and also the lattice energy of some ionic crystal which are difficult to determine by other method is easy. Space lattice. The space lattice is a regular three-dimensional region or atom or ion or molecule. Coordination number. The number of oppositely charged nearest neighboring particles around a particular ion in an ionic lattice is called coordination number of that ion. When itself, the small part of a lattice which sets the pattern or repetition for the whole lattice is called unit cell. A smaller portion of the space lattice which move a distance equal to its own dimension. Various directions generate the whole space lattice. The unit cell of a sodium chloride has sodium plus or chloride minus at each of the corner as well as the center of each face in a lattice. This sodium chloride crystal has a face center cubic lattice structure. Property of ionic compound. Physical state. Ionic substance are crystallized solids. Second, melting and boiling point. The melting and boiling point of ionic solids are usually high. Third, solubility. Ionic solids are usually soluble in polar solvent like water and are insoluble in non-polar solvent like benzene, etc. Fourth, electric conductors in the voltage standard solution. They are good conductor of electricity. Fifth, isomerism. They do not show space isomerism. Sixth, reactivity. The chemical reaction with the ionic compound in solution states are very fast. Covalent bond. A covalent bond is made by pairing and sharing of a valence electron by two bonding atoms, each contributing equal number of electrons in the process of sharing. This bond was proposed by Lewis. When a covalent bond is formed between identical atoms, the bonding pair of electrons share equally by them. Such a molecule is called HOMO. Atomic molecule at the bond is covalent bond. The bond may be single, double, or triple according to the number of electron pairs involved in the sharing. In covalent substance of this similar atom, the bonding pair of electrons shared unequally by the atom. The bond is not purely covalent but has partially ionic character. It is called polar covalent bond. Single covalent bond or single covalent bond is formed by the sharing of one pair of electrons between two atoms. The example of single covalent bond is the formation of chlorine molecule. Two chlorine atoms share one electron each and require stable electronic configuration as shown below. Shared pair of electrons. 287 chlorine, 287 chlorine, chlorine molecule single bound. In general, whenever two atoms of the same element combine to form a molecule or covalent bodies form. Double bond. When a bond is formed by a sharing of two pairs of electrons, it is called double bond. Two horizontal lines between the two atoms denote a double bond. Example: O double bond oxygen O. The formation of oxygen molecule. Oxygen is an example of double bond. Oxygen atom has 6 electrons in its outermost orbit, 2 less than a complete octet 8. Thus, each oxygen atom in oxygen shares 2 electrons with the other oxygen atoms at a stable configuration as shown. Two pairs of electrons share oxygen 2 6 oxygen molecule double bond. Triple bond. The bond formed between two or atoms by sharing of the electron pair is called triple bond. Three horizontal lines between the two atoms denote a triple bond. The formation of nitrogen molecule. Nitrogen is an example of triple bond. Nitrogen atoms have 5 electrons in their outermost shell. Therefore, in two molecules, two nitrogen atoms share 3 electrons with each, thus acquiring the stable structure and forming a nitrogen molecule with triple bond. 3 pair of share electron. N triple bond L. Polar and non-polar covalent bond. A non-polar bond is formed by sharing of electrons between similar atoms. Example bond in chlorine, oxygen, hydrogen. A polar bond is formed where the combining atoms sharing a pair of electrons is similar. In this case, the two atoms acquire a partial positive and negative charge. The magnitude of charge depends on difference in the affinity of electrons of the two atoms. Hydrogen chloride. In hydrogen chloride molecule, the covalent bond is polar coordinate bond. This type of bond is formed by unequal sharing of electron pair. One of the participating atoms provides both the electron pair or lone pair. This is shared by both the atoms. The atom that provides lone pair is known as donor and the other atom is known as acceptor. This bond is represented with an arrow pointing from the donor to acceptor, example NH4. Delta atomic theory NH4 plus. Delta atomic theory. Delta gave the following theory for atoms. Each element is made up of small particle called atom. Atoms of a particular element are all alike, but different elements have different kind of atom. Atom can either be created or destroyed in a chemical reaction. The distribution of atom takes place. In a given compound, the relative number of atoms is fixed. Electron distribution of element. Atomic mass and atomic number of elements are written as AXB, where A is the atomic mass of the element X. The atomic number of the element X is B. 23 and 11. Mean an atom of sodium possesses 11 proton. Atomic mass of sodium is 23 and its atomic number is 11. Stability of inert gases. Except helium, all inert gases possess 8 electrons in the outermost orbit. Since the outermost orbit is saturated, they do not lend, borrow, or share electrons easily. Gases like helium, neon, argon, krypton, xenon are termed as inactive or inert gases. Iron. Electrically charged atom is called an ion. An ion is formed when an atom gain or lose electron. The atoms and ion possess different properties. If the atom gain or lose one electron, it is called singly ionized. If it gain or lose two electrons, it is called doubly ionized, and so on. Cation is formed when an atom loses one or more electron. When a sodium atom loses one electron, it becomes a sodium cation. सोडियम एटम्स इलेक्ट्रॉन लूज करते हो सोडियम कटायन फॉर्म करता है पोटेशियम एटम्स इलेक्ट्रॉन लूज करता है पोटेशियम कटायन फॉर्म करता है एनायन A negatively charged atom or ion is called an anion. When an atom gains one electron, it becomes an anion. Chlorine atom, chlorine anion. Atom is electrically neutral. Ion, it is electrically charged. The charge may be positive or negative. It is not very stable. It is stable. Number of proton and electron are equal. Number of protons and electrons are different. Character of covalent compound. Covalent bond is formed by sharing of electron. Most of covalent molecules exist in gaseous form. Covalent molecules have low melting and boiling points. Covalent compound generally poor conductor of electricity. Covalent compound mostly is soluble in water. Duplates. The tendency of an atom to have two electrons in the outermost or valence shell is called duplet. Atoms of helium is a duplet. Octet rule. The tendency of an atom to have 8 electrons in the outermost orbit is called an octet. It is a noble gas configuration near argon, krypton, xenon, and radium possess 8 electrons in the outermost orbit. The electron distribution of noble gas is shown here in table. Helium atomic number 2, neon atomic number 10, argon atomic number 18, krypton atomic number 36, xenon atomic number 54, radon atomic number 86. Structure of sodium chloride. It is also known as common salt. The distribution of sodium chloride atom in its crystalline structure is shown in figure. Difference between ionic bond and covalent bond. Ionic bond, covalent bond. Solid compound form covalent bond. Generally gaseous compound or molecules are formed. Density is high, density is low. High melting point, low melting point. Good conductor of electricity in molten or dissolved state. Poor conductor of electricity. Bodies formed by electrostatic force of attraction. Bodies formed by sharing of electron. Body inert gases. Inert gases like helium and argon possess fully saturated outermost shell with electronic configuration as shown here. Helium atomic number 2. Electronic configuration 1s2. Argon atomic number 18. 1s2, 2s2, 2p6, 3s2, 3p6. These gases possess limited attraction. Due to fully saturated outermost shell, the bond between molecules of these gases is too weak due to dispersion type secondary bond. Hence, the inert gases show very limited attraction with each other. Ionization energy. Ionization energy is the energy required to remove an electron from a free gaseous atom. It is the most fundamental property of an atom that control electron distribution. Here is the example of sodium atom. When an electron is removed from natural sodium, a positively charged ion is left behind. Sodium energy is absorbed by sodium it forms Na plus and electron is released. Ionization energy of sodium is 495 kJ per mole. Ionization energy decrease as we go down in a group. This is due to the fact that in a group the outermost electron is furthermost from the nucleus and hence less energy is required to remove it. Cesium possesses lowest amount of ionization energy 3.87 ESU. Metallic bond. Atoms in metallic crystals are bonded together by electron cloud. The valence electrons in a metal are not held strongly because metals have very small number of valence electrons. The forces in metallic bond are electrostatic in origin. They can be easily released to the common pool due to weak binding force. The atomic orbital holding a valence electron assumed to merge to produce a delocalized orbital system. Throughout orbit, the electrons are free to move and this permeate the whole metal. Character of metallic bond. J.D. People suggest the following character of metallic bond. First, ability to act between identical metallic atoms and at the same time between widely different metallic atoms. Second, a lack of direction shown by positive rotation of property in the liquid state and of saturation to permeate large number of closely labeled positive nucleus electron cloud. Third, attractive force vary inversely at some high power of interatomic distance. Fourth, ability to permeate electron transfer from one atom to another atom. Fifth, equilibrium repulsive forces which is atomic in nature. Hydrogen bond. The small nucleus of hydrogen containing one proton is attracted by the unshared electron of the neighboring oxygen molecule. This force of attraction provides a bond between two molecular atoms. Special case of polarization, sigma bond. Such a bond is formed by axial overlap of two orbitals belonging to different atoms. It is formed by axial overlapping on SSPP sp orbital. It is denoted by sigma. Pi bond. Such a bond is formed by the sideway overlapping atomic orbital of different atoms. A single bond is always sigma bond. A double bond contains one sigma and one pi bond, and a triple bond consists of one sigma and two pi bond. Bond energy. It is the energy required to break bond and to separate bonded atoms. Bond length. It is the distance between the nuclear bonded atom. Bond length R of different molecule is as follows: HCl 136 picometer, HH 74 picometer, ClCl 190 picometer. Comparison between the various type of bonds. Property. Ionic bond, electrostatic force between positive and negative ion, covalent bond sharing of electron between the bonding atoms. Metallic bond, electrostatic force of attraction, negative electron cloud and the positive ions. Property, approximate range of bond action. Ionic bond 200 to 300. Covalent bond 110 to 200. Metallic bond, character of bond non-directional, directional, non-directional. Bond formation condition for ionic bond is one of the atom has small number of valence electron. Covalent bond atom or two of atoms overlap. Metallic bond for metal having small number of valence electron. Conductivity of ionic bond is low. Conductivity of covalent bond is low. Conductivity of metallic bond is good. Hardness of ionic bond is high. Hardness of covalent bond is low. Hardness of metallic bond is high. Density of ionic bond is intermediate. Density of covalent bond is intermediate. Density of metallic bond is high. Hybridization of atomic orbital. In hybridization, mixing up atomic orbital of an atom to form identical hybrid orbital takes place. Hybridization takes place only during formation of bond. In hybridization, orbitals should not have much difference in the energy. The number of hybrid orbitals formed is same as the number of hybridizing atomic orbitals. Hybrid orbital form sigma bond only. VSEPR theory. This theory predicts the possible Shape of the molecule based on the number of electron pair in the valence shells of the central atom. Electron pair 2. Shape of the molecule linear. Electron pair 3. Shape of molecule is equilateral triangle. Electron pair 4. Shape of molecule is tetrahedral. Electron pair 5. Shape of molecule is trigonal pyramidal. Shape of electron pair 6. Shape of molecule is octahedral. The orbital with lone pair of electrons, the central atom can spread along and come closer to the bonded pair. Due to repulsion, the bond comes closer and the bond angle decreases. Ammonia and water molecule. The repulsion between different pair will be lone pair greater than lone pair, bond pair greater than bond pair, bond pair.